a number of prototypes out there that have demonstrated the capability of hydrogen, and we see fleets of hydrogen operating, of hydrogen trains operating in Europe. So why would we think we couldn't just get on with it? Next slide. And speaking of getting on with it, it's my view that we need to start now. If we're to electrify, and the graph here shows 11,000 kilometers, the traction decarbonisation network strategy, which is the sort of guiding light for the what might need to be done, actually talks about 13,000. But as you can see, we need to do 400 to 500 kilometers a year if we're going to decarbonise over 25 or so years. The issue is, well, twofold. One is, the good news is, as you can see, we've done that volume twice before, in the East Coast era and the CP5 period. So that means we must have the capability and ability to do it. So we shouldn't be too worried about that. The issue, I think, is the gap. We're not doing enough at the moment, as illustrated by that ORR data. Next slide. So just to underline that, last year, in support of the TDNS, RIA surveyed its members on their readiness and capability to do electrification in an exercise we called the market sounding. Next slide. And I've put a bit of traffic light symbols on here. So I'm just going to quickly go through some of the conclusions from that report. So the first and most important one is that what's been asked for by the TDNS, both for infrastructure and rolling stock, is deliverable. But deliverable providing we get the confidence of a pipeline for at least 10 years to support the development and investment that's needed there to get moving on that program. So that drove two recommendations: a long-term collaborative approach, and that is starting to happen with the work that's going on to look at CP7. The problem is, because it's looking at CP7, it isn't looking at CP6. The next bit, about having a clearer pipeline, that has been worked on, we understand, but we haven't seen it yet. So from an industry point of view, we're not able to plan on it. Next slide. So what did the industry say about, or the supply chain say about their readiness to deliver? Well, they unequivocally stated that they have the capacity, that both contractors and designers, that actually exceeds the volume needed. That shouldn't be a surprise, given that we had that capability in CP5. And 75% of those interviewed said that they had already embodied the lessons from CP5 or could do so within 1 to 2 years. And not surprisingly, those most confident were the ones that were currently delivering electrification schemes. Next slide, please. And the rolling stock suppliers also highlighted that they were ready now to privately fund battery and hydrogen solutions. And so that our recommendation was to demonstrate a commitment and stimulate the market by fleet orders in 2020, in 2021. And sadly, that's got a red traffic light against it, because, as I think we all know, that hasn't happened. We also suggested that we should look at how we package rolling stock orders in minimum orders to ensure that there's a sustainable UK capability. Clearly, that hasn't happened because there isn't any orders. Next slide. We also considered the impact on the wider railway system, and we suggested that franchises and concessions should include targets. Now, clearly, there's been a pandemic in the meantime, and the train operator landscape has changed, so it's unclear how that's going to proceed. And we wanted to see further engagement between the suppliers and the train operators and freight operators. And we are seeing that start to happen, and those sort of debates starting to happen about where you would stop one solution and move on to another solution. So a bit of a mixed picture. Next slide. So I just leave you with the message that, given that we have a climate emergency, given that electrification is a better way to run your railway, we need to start now, because we need to be at net zero carbon by 2050. And if we don't get moving, then we will be not only failing to save that carbon, but also at risk of doing it less efficiently than we could. So thank you very much.
Thank you very much, David. A great way to get everyone engaged. More in preparation for our next panel, alternate energy sources, which you'll be on, I'm delighted to say. So if you have any questions following David's keynote or for other panelists as our conversation takes place, please ask on our live Q&A feature, and I'll do my best to get as many answered as possible. Following the phase out of diesel-only engines, and alternative energy supplies are required to offer a greener future for both passenger and freight services. This provides rail the opportunity to form the backbone of the UK's green recovery. Whilst rail has a lower environmental impact than many other means of transportation, the industry is continually working and innovating to reduce its environmental impact more. Electrification has, for a while, appeared to be the most advantageous low-carbon solution, but what alternatives to diesel and electrification are available to lessen further the environmental impacts of rail? Well, here to discuss this topic, including hydrogen, battery power, and electrification, are Dr. Stuart in Railway Traction Systems and Head of the Traction Research Group, Martina Zeiner, Graz University of Technology at the Institute of Railway Engineering and Transport Economy, and David Clarke, who we've just heard from, Technical Director at the Railway Industry Association. Good morning to you all. And thank you, David. I think, gosh, you really set the scene, and I really loved your can-do attitude and your determination that, you know, enough of reports, let's get stuck in and do this, otherwise we're never going to reach the 2050 target. I'd like to start by asking all of you, perhaps starting off with Stuart and then Martina and then David, can rail help to power the UK's green recovery and be a leader, do you think, on the roadmap to a sustainable future?
I think the easy answer is yes, it absolutely can. I think we've got a tremendous history in the UK of delivering, you know, some outstanding rail projects, and you know, now is the time, I think, to take David's lead and get on with electrification, and also look at the other end of the spectrum on the less well used lines, where we think hydrogen and battery technology can tackle decarbonising of those routes. So the technology is mature. I think we've got a fantastic workforce in the UK, and the time's really right to get on and start doing this.
Martina, are you seeing a massive opportunity right now to be a leader with this?
Well, first, thank you for having me here today. Since I'm not from the UK, I can only speak on a broader, from a broader point of view. But I think definitely what Stuart has just said, rail definitely contributes with the technology it now has to reaching to mitigating and the environmental impact. But still, there's a long way to go, and there are aspects we have to consider, but it can definitely help to have a greener future.
And David, what are your thoughts on that? And I don't know, I sense perhaps a little frustration from you that you feel we just need to get moving. Are you seeing things moving in the right direction, do you think?
Yeah, just not fast enough. Rail is unique in all the transport modes that we have all the answers to decarbonising both passenger and freight. No other mode can say that. So we know we have proven solutions. We can decarbonise our system, and in the UK, every year there's 2 million tonnes of CO2 from diesel trains. So, you know, if we wait 5 years, that's 10 million tonnes we haven't saved. You know, that is not a trivial amount of carbon. So we need to get on with it.
And we'll explore a bit deeper, David. But I mean, as you indicated, these things it's not blue sky thinking. These things are happening in other countries, aren't they? So I'm guessing we can talk about what's happening abroad and maybe what lessons we can learn a little bit later. But David, what are the factors in deciding when to deploy electrification or alternate energy sources?
Well, basically, it's a business case, and these days a carbon argument. So it's basically about how many trains are running on your route and the route you're looking at, and also is there any freight. So if there is a significant amount of trains running, passenger trains running on the route, it's probably worth electrifying it. And if there's freight running on the route, you're probably going to have to electrify it, because, as I say, there isn't ready alternatives for long haul freight, whereas there is ready alternatives in the shape of battery and hydrogen for less intensively used passenger routes. So it's no different from what it ever was for electrification. It's how many trains are would be under the wires if I put the wires up.
Martina, why is there a higher grade of development, do you think, for multiple units in comparison to locos?
Well, I think one argument that plays here role is the price and scalability. And when you look, for example, at the branch lines in Germany, where they have now deployed the now commercially available island from Alstom, for example, they have a unit they look at, they deploy a certain amount of well, they have a fleet there with a certain amount of vehicles. But when you then look at a broader scale and at locomotives, for example, that don't just operate on a branch line or on a certain section, but go around Europe from one country to another, there are still barriers. You have then, if you want to deploy your locomotive in several countries, you need harmonized regulations, you need to have certifications. And then also another reason certainly is the differences in power. The vehicles need multiple units that operate on, that are usually lighter, need less power than locomotives that push or pull freight goods.
I'm looking slightly distracted because so many questions have already come in, many of them during David's keynote. So before we move on to hydrogen, Stuart, which I'd like to explore a bit deeper with you, let's just take a couple of questions. James says government has set clear targets for decarbonisation, yet is still heavily subsidising diesel use via red diesel, which significantly undermines the business case for switching, as seen recently with Freightliner mothballing their electric locos. What are the panel's view on whether red diesel subsidy should continue, or what better subsidy regimes could replace it? David, is that one for you, do you think?
Yes, possibly. I'm not totally sure of my facts here, but I think there is thought being given to changing the regime around red diesel. But I think I would make a slightly different point about the recent decision of the freight companies to move back to diesel on a temporary basis. That is not to do with the low cost of red diesel. It's to do with the very high cost of electricity. So as we all are hearing in the news, electricity costs are rising massively. So it's something that is way beyond the control of the rail industry. And regardless of the diesel cost, the issue is that even if you're running a diesel freight train, it's better to do that than have 76 lorries on the road, because that's the comparator. So it's not a situation we want to see, but it's the wider energy costs and the electricity costs that's so red diesel. I'm not totally sure of my facts, but I think that's not what is driving the use of diesel at the moment. It's the extremely high and unused costs of electricity.
And just another quick one for you, David, before we carry on with hydrogen. Jeremy says, David, is 400 STK per year sufficiently ambitious given decarbonisation objectives and what you said about past achievements?
When I did that graph, it was 11,000, based on the 11,000. The Transport Decarbonisation Network strategy talks about 13,000. So that takes you up to 520 kilometres per annum to do it in 25 years. Clearly, if you front load that, then you get a carbon benefit early. But if you front load that, you create a peak in the supply chain, which isn't efficient. If you want cost efficient delivery, a steady program is much better. So I think 500 kilometers a year or thereabouts for for 25 years is a sensible proposition. What I would say is there's interim opportunities to use low carbon rolling stock in the meantime. So there might be interim battery and hydrogen solutions on location, or even more efficient diesel solutions on locations that you might ultimately wire. So why wouldn't you use a battery hydrogen or lower carbon diesel train for the 20 years before you electrify the last 5 years of the electrification program?
Stuart, I know you're probably itching to talk hydrogen. David said in his keynote speech that, there's prototype fleets of hydrogen trains in Europe. And again, I was sensing his frustration that they're not sort of being used widely here yet. Can you just, for somebody who doesn't know an awful lot about hydrogen, can you tell me where we're at and, what are the pros, the cons, and where is hydrogen most suitable in terms of railway applications?
Okay, so just to sort of support some of the things David has already said. So if you want to run really busy, high density, high performance railways, then absolutely electrification is definitely the way to go. And many of our journeys right now are done on electric trains. So if you take a train journey, you're most likely to be on an electric train, probably running around the southeast or on one of our high speed routes. However, we've got a lot of railway which isn't electrified, and there's parts of our railway right at the end of the queue for electrification. And we're looking at hydrogen to provide a solution for those routes. The reason we want to use hydrogen is because it can give you far better range than battery alone. So battery can work in certain circumstances, and it's a good solution. Indeed, it might work for countries like Germany really, really well, and they've placed orders for battery electric multiple units. However, in the UK, we've got lots of rather long lengths of railway with quite infrequent service. So trains every 2 hours or every hour. Those routes aren't going to be economic to electrify in the short term. Maybe 2040 will be really, really good at electrification and can do it cost effectively. But in between now and then, we need to find another solution. And the other important thing, I think, for rail is right now it's far ahead of other modes. But by 2040, if everyone's driving around in electric cars, diesel will become socially unacceptable to use. And a bit like how it became socially unacceptable to smoke in restaurants. The same thing will happen, I think, with combustion engines, because we'll just move away from combustion altogether, and we won't have that anymore. So I think my message is, I'm keen on tackling the lightly used routes, and then at some point, me and David will meet in the middle, probably around 2035, 2040, and we go, well, we've solved it now. The job's done.
I'm just wondering how quickly can the technology be deployed, Stuart? And I suppose from a passenger's point of view, realistically, in Britain, when might I expect to be on a hydrogen train?
Yeah, well, I think this is another important point. So we at the University of Birmingham work with Porterbrook developing their Hydroflex project, and that's in an advanced stage of readiness level now. And they'd be delighted to get an order for it. And there's other people that have got technology that could be deployed in the next few years. So what would be really good, I think, is to get an order for, say a fleet of 10 trains or something like that to run on part of our network, to demonstrate that the technology is viable. And other parts of the world have already done that. So we've had hydrogen trains running in Germany, now in France and Austria. Lots of other countries are doing this. So there's no reason why we can't get on and just place an order, start running it. And I think the key thing is the rail industry is full of very, very skilled people, and them adapting to using hydrogen technology will be fairly straightforward. It's not going to be a big shock to the system to cope with refueling hydrogen trains as opposed to refueling diesel trains. So the message is get on with it.
Get on with it. Same as David. Martina, before I move on to the next question for you, do you have anything to add on the hydrogen front? Are you, can you contribute to that part of the discussion? Is that an area of your expertise or observation?
Well, it's not my direct expertise, but what I can add that is independent from the alternate solution you want to employ, if it is electrification, hydrogen, or battery, because you've all covered those solutions. Yet there are other solutions that are on the market as well, like syn fuels or gaseous solutions. And it always depends, as you've already mentioned, it's a case-by-case study. You cannot just electrify a route that's not dense, where the traffic is not dense at all, because it will never cover the costs. And then you also have to look at it for if you want to mitigate the effects medium, short, or long term, because the gaseous solutions that exist, we know that they have environmental issues as well. And then for all those solutions, you always require an alternative infrastructure as well. You cannot just say, yeah, we'll deploy hydrogen, but we need refueling stations for battery, we need recharging. And it always depends on a case-by-case study. You cannot just draw one conclusion. And then, of course, another aspect that has to be considered, and I think is very important as well, is that when you have battery or hydrogen, for example, we always talk about zero emissions when having those solutions, but you need energy in order to then transfer the energy from the source to power the vehicle. And it also depends on the country, on their electricity mix, because if they don't have a very sustainable electricity mix, it's a question it's a balance. We also need the infrastructure in order to employ it then.
Thank you, Martina. I think we're just going to flick back just to finish off on hydrogen, Stuart. Michael says, will the UK have a sufficient supply of green hydrogen to power the number of hydrogen chains we might need? Or is the move to hydrogen chains predicated on the use of blue hydrogen and carbon capture and storage?
I think the answer is going to be a mix of both. So as the country starts using more hydrogen, we'll probably have competing sources of hydrogen, and it's perfectly possible to produce high quality pure hydrogen from steam methane reforming. But a key part of that is to bury the CO2 under the North Sea, or somewhere similar, to trap it in the geological architecture that we've got there. That's really important. But ultimately, the best way of producing hydrogen is from renewable electricity that's connected to electrolyzer. So we just need wind turbines or solar connected to electrolyzer with a supply of water, and then we can make the hydrogen without any fossil fuels being involved at all. So ultimately, that's what we want to do. But recognizing that we need a lot more wind turbines and solar, and a big growth in a supply of electrolyzers into the industry.
You make it sound so easy. I love how easy you make it sound. David, I haven't forgotten you. I'm coming back to you in a minute, but I've just got another hydrogen question that's popped up, and then we'll move back to David. Michael says, Stuart, most approaches to hydrogen traction to date have been via the fuel cell, involving the use of heavy and expensive fuel cell equipment, traction motors, and associated control electronics. What are your thoughts on hydrogen IC engines? Obviously less efficient, but potentially lower cost and lighter. Might this balance the high costs and mass of FC systems?
Well, I don't think there's a massive difference between the prime movers. So a fuel cell is an expensive piece of equipment, but also a diesel engine that would be used to provide propulsion for a diesel vehicle operating on the rail would be quite expensive as well. So there's not a massive difference. So a fuel cell train isn't likely to cost a great deal more than an equivalent diesel train. So the cost issue isn't significant as people might think. I think where that misconception comes from is a fuel cell car is often very expensive at the minute, because it's a lot more complicated than a battery car. But for a train, the propulsion system is only a small part of the overall cost of the train. And even if it's a bit more, it doesn't add a massive amount onto the total cost of the train. However, saying that, we've got a lot of combustion equipment in the rail industry, and I think being agnostic about this, we need to think: can we use some of the existing combustion equipment and convert them to hydrogen combustion? That might be a solution for some of our existing engines in the sort of medium term.
Brilliant, thank you. David, you sort of whetted our appetite a little bit in your speech about Germany and what's happening internationally. What inspiration, what can we draw from what's happening in other countries, and who are the best examples, country-wise, who are doing the right thing and getting there quicker than us?
Okay, well, I mean, first of all, we start from a less good position in terms of electrification. So most European countries, their networks are about 60% electrified. In the UK, we're only about 40% electrified. So we have some catching up to do before we move on to decarbonize. I think we have data for Germany, as you've already seen. We've also looked at Switzerland and Denmark. And in all those countries, they have understood that giving a consistent volume of work drives efficiency. And on that graph of costs that I showed, they were all at the lower end of the spectrum. So Denmark, Germany, and Switzerland, the general public would probably not think of them as low cost economies. You would probably think that the UK could be at least as cost competitive as they are. Why aren't we as cost competitive at the moment? Because we're doing work in fits and starts. Yeah. So if we smooth that out, we become much more efficient, and the evidence is there from looking at those other countries. We also see around Europe, we see hydrogen trains being rolled out in the kind of fleet numbers that Stuart's talking about. Likewise, battery trains. We actually, we have momentarily got quite a leading position in our skills around battery and hydrogen. But if we don't convert that into, we're up there with the leaders around Europe at the moment. But if we don't convert that into fleet orders and actually start building the things on a fleet basis, both battery and hydrogen in the UK, then we'll lose that lead and we'll be buying from other people. And if we think about the UK economy, that's not a good position to be in.
It certainly isn't. Martina, when we look at the market and we look at different modes of transport, I think it's quite obvious, isn't it, that the automotive sector is probably one of the most advanced and developed in terms of alternate propulsion systems. Can we copy and paste for the railway sector? Can we take some lessons from what's going on in the automotive industry?
But unfortunately we can't, because we've heard propulsion systems and transmission systems, and for example, just that is different in automotive, like in passenger vehicles, than in trains, for example. And another aspect that is also certainly true for rail is that we have different weight and space requirements for the vehicles. The batteries that are now on the market are really heavy, so it would require further development, for example, as well. And then also batteries that are used in the automotive sector, some of them, well, all the battery technologies, every battery has different characteristics. One outperforms the other in energy density, but then the other one is safer than the other. And especially safety is an aspect in the rail sector that is very prioritized, I would say. So you cannot just take a passenger car and take out the transmission or propulsion technology and put, and then yeah, that's it, I think.
You mentioned batteries there, and David, in your speech, you talked about batteries having a key role. Stuart, what are the possibilities, do you think, for battery technology?
Well, I think there's some really nice examples in Europe about how battery technology is being used in conjunction with electrification. So in places like Germany, and Germany is very different geographical arrangement of its cities, and it's got lots of big cities, nothing quite like London, but and is spread about. So the electrification in somewhere like Germany is fairly comprehensive, but there's quite a lot of gaps that are around 50 to 80 kilometres between bits of electrification. And currently they were running with diesel vehicles, but now battery electric multiple units can serve those routes really well, where they run along using electrification, charge up their batteries on the electrification infrastructure, and then they'll run on part of a network which isn't electrified in battery mode. And then say an hour later, after they've done 80 or 100 kilometers or something, jump back onto electrification. So in certain parts of the world, there's battery electric multiple units who are really good application. And I know we're primarily talking about heavy rail here, but also, I'm from Birmingham, and our tram system has been fitted with a battery, so it can go through the centre of Birmingham without the need for catenary to be put up. So there's lots of applications for batteries in the rail industry. And just finally, a fuel cell train effectively is a battery electric multiple unit, where we use the hydrogen fuel cell system effectively to continuously charge the battery. So it's effectively a battery train with a onboard inbuilt charger that continuously tops up the battery.
We've got you're not finished, Stuart, I'm afraid, because questions are flowing in, and we're back to hydrogen. Ewan says, should we be retrofitting hydrogen or battery into existing vehicles or buying new rolling stock?
I think the answer is to do both. We've got a great history in the UK of making good use of our rolling stock, and there's some really nice trains that are running around now that are quite old, that have been refurbished and re-engineered over their lifetime. So we've got a big industry that's capable of doing this in the UK and doing it very successfully. So I think and ultimately that's probably quite a good thing from a sustainability point of view. So if you've got a vehicle that's pretty much all intact, you can re-engineer it for a fraction of the cost of buying a new vehicle, and then it can run around for another 15 or 20 years. So that's it's a bit like reuse, recycle kind of argument. Or upcycling vehicles is a really good thing to do. But equally, we need to encourage the supply industry to develop new vehicles as well. So I think the answer is a bit of both, and hopefully we'll see a bit of both coming into the UK.
And Rob's just saying, Stuart, I mean, do you foresee a challenge branding hydrogen to the general public?
Not really. We at the university we had a small demonstrator train that's been running since something like 2012, and we've exhibited it to thousands of people and allowed lots of adults and children to take a ride on. It's a narrow gauge fifth scale train. And when we explain to the public how that's running off hydrogen, they're just really interested and think that this is a nice, quiet, clean technology to use, and people are quite happy about it. And it is very clean, and you also don't get any of the problems in terms of air quality from a hydrogen train, because the only exhaust at point of use is sort of damp, hot air.
Brilliant. Another question for David, which is coming from Chris. Does David think the introduction of GBR will change the way longer term plans around decarbonisation will come forward? Better integration between rolling stock and infrastructure?
Well, I certainly hope so. The GBR, Great Britain's Railways, is sort of a creation of the Williams-Shapps plan, as I'm sure Chris will know. And that talks about one of the key commitments being a 30-year plan, and not just about decarbonisation, a 30-year plan for the railway, and much closer alignment between infrastructure and rolling stock. There's an awful lot to like in that plan. The challenge is about delivery, and our immediate issue is that because it requires primary legislation, it's going to take 3 or 4 years for GBR to be fully in place. They'll have a shadow team in place next year, but it won't really be fully in place until 2024 or 2025. And our concern is that in the meantime, there's a hiatus, whilst waiting for what will hopefully be a much better structure for the industry. We make no decisions in the meantime. and that would just be treading water and not saving carbon.
Martina, one thing we haven't really touched on is track work machinery, obviously very much part of the railways. I mean, can you summarize some of the trends and the problems we might face there?
Yeah, correct, because we mainly talk about mainline locomotives or lines on branch lines, but the CO2 emissions of track work machinery is often, well, is often not considered at all. And that when you look at track work machinery, where the electrification rate is not existent, I would say, because they're mainly operated by diesel engines and they're operated worldwide. So that is also an issue that has to be considered. But the industry is taking the initiative. There are the alternative solutions are gaining popularity. There are some hybrid solutions now which work on diesel and battery. And for smaller machinery like handheld equipment, for example, there are battery solutions, but of course these batteries have to be smaller in comparison to machinery that is tamping or relaying the whole track, which requires much more power, which would then not have the perfect solution with the battery, but then fuel cell solutions would be good alternatives. But still, there is a trend towards alternative solutions, but the developments are in their infancy. And yeah, there are also have to be dealt with and barriers for that industry, because since it operates worldwide, there are different regional and technical boundary conditions, I would say, so because construction sites don't have the same requirements in every country. There are different maintenance regimes, there are different shift lengths, everything. So these projects have to be even more tailor-made than railway vehicles, I would say.
We've got 1 minute left. David, in your address at the beginning of this, you said there was a report out yesterday, Net Zero Strategy, Build Back Greener. There are reports out most days, and of course, reports and research are all key when we're looking at the railways. But you used the phrase there, the challenge is on delivery. Can you leave us with a final thought about how optimistic you are about whether enough action is going to be taken and taken quick enough to realise the ambitions that are there and the opportunity that exists now for rail to be sustainable and eventually net zero?
I wish you were asking me this next week.
Why?
Because the spending review is next Tuesday, and we should know what the government's attitude is to these issues and how much money they were able to put behind it. And clearly, the pandemic has cost the Exchequer an awful lot of money, so they're going to be looking pretty closely at expenditure. But in a situation where we're about to host COP26, and the UK, in strategy terms, has a really strong leading position on decarbonisation. Let's hope they don't want to be open to criticism that they're not turning strategies into action. So I would like to think, I'd be optimistic that there will be some kind of announcement showing a step in the right direction between now and early November when it's COP26. If there isn't, I think we're missing a huge opportunity. And I go back to the point I was making before about the cost of waiting. If we save a ton of carbon this year, we've saved 29 tons by the time we get to 2050. If we wait till 2049, we only save a ton. So we have to get on with it. That's my simple message. And in the normal course of circumstances, the way railway funding works, we won't. There's a risk we won't get started on it until at least 2024, and that's just lost time.
Yeah, it's too far away, isn't it? We could continue this discussion for much longer. I hope you'll all join us actually on a future rail discussion, and obviously that will be post Tuesday. So let's keep everything crossed, David, for Tuesday's meeting. Thank you very much, all of you. Thanks to everyone who took part in this panel, and an extra thank you to David for doing a bit of a double whammy there, being a keynote speaker and panelist. And thank you to you for putting so many questions across. I think we managed to get pretty much all of them in. So thank you. It really is brilliant to make these debates a conversation rather than me just posing the questions. We're going to take a break now, which means another opportunity to network with other delegates. It's also a chance to recharge and process all the knowledge and information that's been shared already. So enjoy. Our next session we've run over, so I'm guessing our next session will be probably in about 10 minutes time, I think. I'll see you back then.